This video is going to create the fluid volume and then mesh that for the fluid in an artery. This artery has a mechanical heart valve on the inside. That will be a topic for another video, so that's not going to be considered, but we will be opening this component and cleaning the geometry up a little to make it correct for meshing. And I'm just going to copy that plane into this component so that we could use that plane and look at a cross-sectional view. And there's two defects to fix in the geometry. One is very obvious, is this step in the wall thickness, which doesn't look like a piece of a real artery. And so we can simply, with the select tool, pick, not in section view, but in 3D view, we can click there and control click there and hit the delete key to get a full thickness artery wall. And the other defect is a little harder to see, but I'll zoom in a section view. It's this. There is a extra face and a little step to close the gap between the heart valve housing and the artery, and that's not something we want in the fluid flow simulation of the artery itself. So to delete that will be best if we, since it's hard to get to, we could either split the solid in half and then unite it back together, or hide some outside faces. And so I'll try that approach of hiding some outside faces. So if I hide these faces, which is hide faces, what's left is the faces on the inside of the part. And this, I can hit the delete key and maybe undo that. Sorry, it's this and the two adjacent faces, control key, that one, and control key, that one. Those three faces, not the edge, the face, those three faces are now gone. And if I, these surfaces represent the inside of the fluid volume, I could just delete these end faces and we would have a fluid volume, but I'm here to demonstrate how to extract the fluid volume. So I'm going to show all, so we're looking at the outside faces again, but now we've gotten rid of that step in the wall. While we're here, we will look for any other defects on the repair tab. Is there any extra edges? No. Or extra split edges? No. So no bad geometry here. So we're going to do the prepare volume extract, and it wants to know the faces that cap this off. There's that face, control key, that face, and then pick a face that's on the inside. There is now the fluid volume. So I'm just going to relabel that fluid and drop it up here, and this, rename that, that's the wall. So for fluid flow, in this simple example, we're not going to mesh the wall, so we're going to suppress that so it doesn't get sent for meshing. And go back to the select, tool so I can just delete the container. So there's a fluid and a wall, and we don't need the wall. So there is the fluid, and this is a very clean piece of geometry now. So we will hit File, Save, and we will import this into mechanical. So here we have mechanical, and for Fluent, we want to have a mesh component that will then easily link up with a Fluent system. So we're going to bring that geometry in. We'll browse and did not save that yet, so let's cancel. This has not been saved separately from the try2. Here we can just suppress for physics the heart valve, and the only thing that will come in is the fluid. So I'll hit save on this, and that's not a separate file yet. So I can simply import try2 and open the mesh. So that's starting meshing, and we'll just pause a minute while it loads. So it didn't bring in the wall, but I can simply suppress that body to ignore it, and we'll go on with meshing this. And this is going to be defined as a fluid, and the mesh properties are not for mechanical but for CFD, and maybe we'll go for a 3mm element size. We want inflation layers, so we're going to insert named selection, and with extend to limits, pick up all of the outside, and we'll call this inflation. Walls. So when we go to mesh, we want inflation to be automatically applied to all the faces in inflation walls, and we want first layer wall thickness of 0.1, and we want 10 layers. So let's go ahead and mesh. And there is a very nice mesh, and we've got the good inflation layers working. We will have a slice through this by doing on the Home tab or the Display tab. Section views. Not seeing it. Oh, section plane, there it is. So we can draw a section plane through here, and we can, on the section plane, turn on full elements, and now we see a beautiful inflation layer through the length of this. So that was the goal. While we're here, let us also turn off the section for a minute and make a few more named selections. N for named selections, and call that inlet, and N for named selections and call that outlet. And this is all the information that Fluent needs to bring that in. So simply update the mesh and bring that into Fluent for defining the boundary conditions at the inlet and outlet. So that will do it for this video. Thanks. Bye.